Product properties of exponents. Lesson 7.1. You're watching this video with Ms.Y. Cavazos. So, product properties of exponents. Exponents means exactly what it is. Powers, exponents. So we're going to be working with exponents, and we're going to use two main properties in today's video. The first property is the product of powers. So, product of powers means when you multiply two powers that have the same base, that is our main key point, same base, we must keep the same base and we get to add the exponents. So let's see how this works. Example, simplify each expression by applying the product of powers property. So it says, when we're going to multiply two powers that have the same base, so you should think, okay, this is a base. Are they identical? Identical. Yes, they are. When they're identical, then we are allowed to move on with the property, and it says to go ahead and add the exponents. So 3 plus 4 is 7, so our answer is n to the 7th, or n to the power of 7. Now, some of you might be wondering, how does that work? Well, think about it. Here we have n to the power of 3. If we could expand, this means that we have 3 n's that are multiplying each other. We also have n to the power of 4, which means if we expand, there are 4 n's multiplying each other. And if you stop to think and look at what's in front of you, we can see that there are how many n's in total? 7. And guess what? Same answer. But instead of doing this whole mess, this whole process, instead of showing all the work, because some of us are lazy, the fastest way is to, boom, just use the property. Let's try other examples. In this example, we notice something slightly different. We notice that there is an 8 involved, a coefficient of 8. So let's go ahead and just take a moment, pretend the 8 is not there. We look at what we have. So again, think of the property. It says, if the bases are the same, here's the base, they're both w's, so yeah, they're the same. So we have w to the 6 times w to the 5th, same basis, so instead what we can do is apply the property that said add the exponents. Now that 8, we can't ignore it forever, so I'm going to bring it back. That 8 is still coefficient, and it's going to go in the front of w. And we add the exponents, so we get w to the 11th power with a coefficient of 8. Nothing else we can do, so this would be our final answer. Our next problem looks different than the previous one. What makes it so different? Parentheses. But if you remember, parentheses still means to multiply, so this is just multiplying. So now these two problems look identical for the most part. Okay, what also makes this problem slightly different is that now we have two coefficients, two large numbers, if you want to call it that. Okay, so what we're going to do is we're going to separate some information here. We're going to put the 2, the time multiplication symbol, because everything is getting multiplied here, and the 7, because those two are coefficients. And they're going to multiply. Then we can focus on our exponents, and if we look here, they do have the same base. So this is y to the power of 4 times y. Y doesn't have a power that we can see, but you need to know that anytime there is a y, there's a power of 1. Okay. So what we can do is we can go ahead and add those powers. Okay, so I'm going to go ahead and do that in this step. There's a power of 1. and we simplify to get our answer. We're going to not evaluate it, we combine, sort of say. So 2 times 7, we said we need to multiply. That gives us 14. The y has a power of 4 plus 1, which is 5. And we have our answer here in simplest form. Next problem. As you can see, now it has 2 types of variables. And that's fine. Again, just remember parentheses means we are still multiplying, so nothing different. So I'm going to separate the information that we have here. I'm going to color code my m's. As you can see, these have the same base. And my p's, because these have the same base. So my m's, I'm going to move them together. M to the power of 8 times m to the power of 3. And the same with my p. So I included this step so you can understand what we're about to do. Since the bases are identical for the m, that means that we get to add the exponents. And that gives us m to the power of 11. Same thing with our p's. This becomes 9 plus 2, which so happens to also give us 11. So p to the 11, and that is our simplified answer. Nothing else we can do. Next one. So now we have coefficients. We have 2 different variables. So here's my w, and we also have x's. So x's. Alright, so there's 3 different things. So what I'm going to do is I'm going to separate these 3 things. So this is negative 14. And I'm going to keep it in parentheses because we are multiplying in the end. My w, this w has a power of 1 times w to the power of 5. And because they have the same base, what I can do is already set it up where I can add the exponents. Then I have x squared times x squared, but clearly we can see that they have the same base, so we can apply the property and add the exponents. So we get that the product of negative 14 and 6 is negative 84. W to the 1 plus 5 is w to the 6. X to the 2 plus 2 is x to the 4th. And that is our simplified answer. Okay, this problem is different. It's asking to express the area, that's important, of each figure, or of this figure, as a monomial. Hint, the area of a rectangle, if you forgot, is length times width. So they're asking us to find the area by multiplying the length times the width, something that you've been taught how to do since maybe 4th grade. So we have information here. We have a length and we have a width. Or if you want to call this your length and this your width, it really doesn't matter. We can do that. Okay, so our length, we know clearly that it is 10k to the 9th and h to the 8th. We're going to multiply times the width, which is 3 h to the 12th and k to the 5th. Well, just by doing this here, by showing this, this looks just like the problem, very similar to the problem that we did before. So we have coefficients, and we have our coefficients here. So those two go together. 10 times 3. Now I'm going to change this up a bit because you might think that the point in the middle is a decimal, and it's not. It's a multiplication symbol. So I'm going to use parentheses, 10 times 3. Then we have our k's, which we clearly see are the same base. this k, and this k, same base. So we can apply the rule that says add the exponents. Then we have h. So we have h here, h here. So that means h, same base, so we can go ahead and add the exponents. I'm going to rewrite all this mess, and we get that 10 times 3, the product of 10 times 3 is 30, k to the 14, and h to the 20. Nothing else we can do. Our answer is simplified, and we are done. Moving on to the second property. It says, power of a power. When raising a power to another power, you're going to keep the same base and multiply the exponents. And that is what we see in this illustration right here. So let's go ahead and apply that. In this example, we have c to the power of 6 inside some parentheses, and then this is called the outside power. It is raised to another power. So we are going to apply the property that says multiply. And that is c to the 6 times 3, and our answer is c to the 18. Simple. Next one, d to the 4th, and that is raised to another power, which is 7. So we have a power raised to another power, which means, we can multiply them. So that gives us d to the power of 28. Simple. Then we, of course, because math is not always simple, we come across this here, coefficient of 2. So what do you do when there's a coefficient of 2 there and a d here? Well, think about it this way. If we split these two up, this is 2 to the 5th and d to the 8th raised to the 5th. Going back to this 2 to the 5th. This 2 has a power of 1, and it's being raised to the power of 5. So that means 2 to the 1 times 5, d to the 8 times 5. We get to multiply the exponents. So it gives us 2 to the power of 5 and d to the power of 40. But this answer is one in specific, which is 32. So our final answer is 32d to the 40. This is what we call a simplified answer. Not this where we have an exponent where an integer has an exponent. This is what we call the final simplified answer. All right, let's try another one. So again, we have two different variables inside the parentheses. So what we can do is split them up. So think of it this way. G to the power of 2 is being raised to the power of 9. H, which has no power, so we think, but really there's a 1, raised to the power of 9. So remember, what we can do is we can multiply these powers, h1 times 9, so we can get our simplified answer. So this is g to the 18, h to the 9, and that's it. Nothing else that we can do. Next problem, of course, we had to keep expanding a little bit more. So I'm going to separate all these three things. So this is 2 that has a power of 1 raised to the power of 4. Then we have w to the power of 3 raised to the power of 4. Then we have x to the power of 5 raised to the power of 4. So each one is being raised to the power of 4. So we can say, okay, that is 2 to the 1 times 4, 3 to the w to the 3 times 4, and x to the 5 times 4. And we get our answer of 2 to the 4th, w to the 12th, and x to the 20th power. Of course, this is not simplified enough, so we need to write it as a number without an exponent. And we get 16. I'm going to write the w a little closer to it and the x a little closer to that. And we have our simplified answer. And now we have the challenge question. It says, simplify each expression by applying both properties. So the two properties that we learned is, if the bases are the same and they're multiplying, you are allowed to add the exponents. We also learned that when you have a power raised to another power, you are allowed to multiply those two powers. So keeping this in mind, we're going to use it for this challenging problem. So if we look at this problem, there's something that stands out, this power of 5, and it belongs only to this here. So we're going to do what we did earlier, where we're going to apply this to the 3, to the x, and to the y. We're going to multiply that power to each individual one. So this is 3 to the 1 times 5, x to the 8 times 5. Oop, what did I do? And y, which has the power of 1, times 5. I'm going to write this over here on the side, times 4x squared y squared. So then we get that this is 3 to the 5th, x to the 40, and y to the 5th, times 4x squared y squared. Before we write our final answer, we need to put these two together. And remember, everything is multiplying. So I'm going to write them next to each other with parentheses, because that means to multiply. And I'll put parentheses around that one too. Then we have our x's. And because we know they have the same base, that means we can apply the first property, product of powers, and we can add the exponents. Same thing for the y. So we have the base of y, and they're identical. So that means we can add the exponents. Okay, so then we have to type, be careful with how we type or how we figure out what this product is going to be. And we get 972, because again, in case you've forgotten, this is saying 3 times 3 times 3 times 3 times 3, 5 times. Then that answer, we're going to multiply it times 4. So we get 972. X to the 40 plus 2 is 42. Y to the 5 plus 2 is 7. And now, finally, we have our simplified answer. And we used both properties, so really it's not that bad. Thank you for watching.